We made a Minesweeper app that allows the user to play Minesweeper at 4 different difficulty levels on a 10x10 playing grid. Normal Minesweeper increases the grid size based on its difficulty, but varying the grid size in our app would have required even more buttons and would have made the game difficult to play on a phone. Instead, we chose to have the difficulty correspond to the percent chance that any individual button contains a mine. After the difficulty is chosen, the game board is activated and we can begin playing. When we click on a button, it will display its contents. This will either be an X if the spot is a mine, a positive integer if the spot borders one or more mines, or a blank spot if the spot borders no mines. Clicking on a button also disables it from being clicked again. When a mine is clicked, the Game Over message will appear at the bottom, along with a score and a half-second vibration. Hitting the mine also disables the entire grid. If the user clears the whole board without hitting a mine, the victory message will appear, along with a 1-second vibration. For this video, we adjusted the difficulty setting so that we could easily show the victory screen. We chose to make a Minesweeper game because we both enjoy the game and thought it would be a fun exercise to practice coding an app. In this code, we have initialized all of our buttons, and then on the onCreate, we use the setup and disable grid methods to initially set all the buttons to their respective ID buttons, and then disable the entire playing grid so that none of those buttons can be clicked. For the 4 menu buttons, we have 4 separate on-click listeners. We'll look at easy for now. When the button is clicked, it will disable the menu, which basically disables the menu buttons and makes them invisible. Then it will set the percent to the appropriate percentage. It then creates the board, which uses a double for loop and a random number generator to indicate where the mines should be placed. When the double for loop dictates that a mine should be placed at a certain location, the 4 if statements will update the surrounding buttons if needed. Once a menu button has been selected and the percent has been set, the play grid will be activated by enable grid. Once that happens, all of the 100 game board buttons will be available. We'll look at the first button as an example. When the button is clicked, it will be disabled so that it cannot be clicked again, and the score will be incremented. Then the method checks to see whether it holds a positive integer, which indicates the number of mines around that spot. If it's negative, which will trigger the game over method. If the spot on the 2D array is a 0, that indicates that there are no mines around that button. And this won't make the button display anything in order to make the grid less distracting.
One issue we encountered was with our menu. We originally wanted to create a separate menu page that would hold 4 difficulties and then open the game board when the difficulty was chosen. For some reason, whenever the difficulty was chosen, either the game board would appear but be unresponsive, or the app would crash after opening the game board screen. Due to time constraints, we decided to move the menu to the same .java and .xml file as the game board. We did all of the coding for this app on one computer. This allowed us to use the second computer to test our smaller parts of our code on simpler apps. We used this technique to test our haptic feedback, test the different layout options, and to figure out how to switch from activity to activity. We also shared the working parts of the practice code over Google Docs. In the future, we could try to figure out a way to get the menu page to appear on a separate screen instead of above our game board. We would also like to implement some sort of flagging mechanism to allow the users to mark potential mine locations. We would also like to see if we can get the sound to work so that we can have victory sounds and explosion noises.